circuit, electronic circuit. But even microcontroller, yeah, even microcontroller also is possible, right? Through a programming, it is possible to generate a waveform. So now let us see how to interface a circuit. Okay, so how to interface a circuit which generates square wave, triangular wave, and sine wave. Right, that can happen through a circuit which is called as DAC. So what this microcontroller does is it will send some data. Okay, so this microcontroller will send, this is MUC microcontroller. It has ports, okay. So you can choose any of the ports, port 0 or port 1. We know that ports are used for transferring the data from microcontroller to external devices, or okay, from external devices to microcontroller. So to generate this, any kind of waveform, so we need to send the data from microcontroller. So you are writing a program here and you are storing that program in the memory. Okay, so and this data that is necessary for generating any of the waveforms what is mentioned just now. So that data will be placed onto this port. Okay, so whatever the data that you are placing onto this port, say for example, if you want to generate a square wave. So what is the square wave? Square wave has two different levels. Okay, so you can see this is the square waveform. This is a digital signal because it has only two levels, 0 level and 1 level. Such a signal we call it as a digital signal, whereas triangular and sine wave we cannot call it as a digital signal because its value keeps on changing at every instant of time. You see here, at every instant of time, magnitude is different. Magnitude is different. Even sine wave also. At this instant, its value is different. At this instant, its value is different. At this instant, its value is different. Okay. And it is not only two values, it has multiple amplitudes are there within a given amount of time or in a given period, or in a given cycle. But in a given cycle, square wave has only two levels. Okay, so this is a complete cycle. Okay, so this is on time and this is off time. Okay, so in an entire cycle or in given time period T, or this is one complete cycle, we find that square wave has only two levels. Okay, so one level, logic 1 level and logic 0 level. So then to generate such a waveform, okay, right, what is that we need to do, what microcontroller should do? Microcontroller need to send some data, okay, via this port to a device. What are we doing here? We place some data. So what actually is required to generate a square wave? So for some interval of time, you need to send logic 1, okay, via this port. You need to send logic 1 for certain interval of time. So already we have done one kind of this circuit, LED circuit. So how did we blink the LEDs? Okay, so we sent logic 1 for certain interval of time through the port. Okay, and we created a delay, and after certain interval, again we sent logic 0. So for certain interval of time, all the 8 LEDs were on, or after certain delay, all the LEDs were off. Okay, so similarly, here also, if you want to generate a square wave, it is necessary that you have to send logic 1 for certain interval of time, right? And logic 0 for other certain interval of time. So if both the delays are same, then it is a square wave. If both the delays are different, then you can generate a rectangular waveform. Rectangular means on time is different from the off time. So here you see, this is one cycle maybe, on time is more than the off time. It is a digital signal, no doubt. Okay, so it has only two levels. Okay, but it is not a square wave, it is a rectangular wave, where we see that on time is more than off time, or off time can be more than on time. So anyway, by creating a different delay periods, it's possible, okay, to generate either maybe a square wave or maybe a rectangular wave. So hence through programming, it is possible to generate in general a rectangular waveform. So now when on and off periods are same, we call it as a square wave. Equal intervals, delay intervals are there. Okay, so now let us see. Now logic 1 has to be passed, so then place 1, 1, 1, 1 here. So that means FF. 8 pins you can take. So 8 pins as usual you can take from P0.16 from P0.23. Okay, so 8 pins you can take, on all the 8 pins you pass 1, 1, 1, and where this one will go. So this ones will go to another circuit which we call it as DAC. Okay, so this is a DAC circuit. Whatever the IO register, IO port will send the data that is connected to a DAC here. Right. All the 8 pins of port 0, 16 to 23 are connected to, okay, data lines of this DAC register. Usually, whatever the DAC interface, whatever we are studying, right? So it has 10, right? So 10 pins are there, 10 bits are there. It is 10-bit D to A converter. What's the meaning of this? So at a time, it can convert 10 bit of digital data into analog output. What is this? This is analog output. What is the input that it is taking? Input is applied in the form of bits. So how many bits you can apply? That depends on the capacity of the DAC. Some DACs will be converting, okay, 8 bits. Some DACs will be converting 10 bits. Some DACs will be converting 16 bits. Okay, so this DAC, whatever you are studying in your lab interface, right? So it has 10 bits. So here, this DAC has a register. So we call it as a DAC register will be there. So whatever the data that you are sending out of this port 0 or port 1, so whenever you connect these lines to this DAC, it is an IC actually. Okay, this is a circuit. Within this, it has a DAC register. So this DAC register is a 32-bit register. Okay, so 32-bit data, anyway, port is a 32-bit line. Okay, so this 32-bit data that is sent by this port will go and occupy this 32-bit register that is present inside this DAC. Later, so this DAC, okay, has a circuit internally. All right. So takes the data from this. Right. Whatever it may be, though the length of the register is 32-bit, but it will take only 10 bits from this. Okay. Right. So only 10 bits in that register have some meaning. All other bits doesn't have any meaning. I think it is from D16 bits, no? So hence it is D6 to D13, I think. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. How many bits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15. Okay. So D6 to D15. So these bits in DAC register, okay, so are meant for receiving the data because it is a 10-bit data converter. It converts 10 data lines, 10 inputs that is received from the microcontroller, okay, so into a valid information, valid analog information. All other bits are not going to be used here. Follow this? What is DAC register? DAC register is a 32-bit register. Among the, all the 32 bits, only the bits from D6 to D15, okay, are meant for receiving the data from microcontroller. So totally 10 bits. Even you can send 8 bits only, upper 2 bits will be added. Okay, so even if you add upper 2 bits also, it doesn't have any changes in the magnitude. Okay, so this 00 FF, okay, one F is 4 bits, other F is another 4 bits. Totally 10 bits will come and sit in this DAC register, and then this DAC circuit will take the data from this DAC register, and that will be converted into equivalent analog output. Follow this? How actually the things are done? So we take a microcontroller which has 2 ports here, port 0 and port 1. So for time being, we are taking port 0 for all purposes of interfacing. So here you are usually taking P0.16 to P0.23, 8 data lines are there. Okay, 8 pins are there. Okay, so we are placing the suitable data using suitable register. It may be IO pin register. We place a valid data into IO pin register. That in turn places the data into this port 0. Okay, so as soon as we place the data onto this pins P0.16 to P0.23, the lines are connected to the data lines of the DAC register. Okay, later the data present on this data bus of DAC register will go and sit in DACAR register inside. Okay, what is this DACAR register? It is a 32-bit register which receives the data from microcontroller sent by the port. Okay, so then among 32-bit bits present in this DAC register, so only the bits D16 to D15 has the valid meaning, correct meaning, right? So whatever the data that comes to this bits, D6 to D15, totally 10 bits are there, okay, right? So then this will be converted into analog output. So digital data that is arriving in, okay, by using a suitable circuit within this, it will be converted into analog output. Follow this? So this is the interface. So now we have to write a program for this. So I will write the program later in the material. No, I'll be writing this block diagram also, and I'll be giving you. Okay, right. So just you understand the concept how actually the things are happening. Now we have to write the program. Let's just erase it. Now I hope you have understood what is the logic behind this. What actually should be done? Write the program now. Okay. So what is the header file used? .h. Right. Next. What actually, see, before starting the program, you should know like what are the requirements of the program. What are the requirements of the program? Tell me. What should be done? So, say for example, write a program to generate a square wave using. Okay. I hope you can copy this thing. Before this only I should have told. Okay, program to generate a square wave. Here only I write. Program to generate square wave. This is the problem statement. Okay. So now you have to generate a square wave. What should be done? Tell me the requirements of the program. I mean the task. So you are given a task now. What is a task? Task is to generate a square wave. How? Using a microcontroller. Okay. So now what is the first step? What's the first step? You have to make ground preparation, right? What are the necessary points to be noted here? Come on, answer. Unless you think something, no, like things will not proceed. What should be done to generate a square wave? Tell me. What is the data that should be sent to the DAC? What data you need to send? Come on, answer.
We should send ones and zeros, ma'am.
Ones and zeros you have to send, right? So now, see, you have to use, let me use IO pin register, IO0, PIN register. Okay, what should be its value? IO0 PIN register is a value register. So now we know that we need to send logic 1s for certain interval and logic 0s for certain interval to the DAC. So what should be the value of, if you take the pins P0.16, okay, to P0.23, 8 pins if you take. Okay, so even 10 pins also you can take, no problem. Okay, so let us take 8 pins because DAC is 10-bit register, you can take 10 bits also. So let us first explain for 8 bits. IO0 PIN register value should be what?
0x.
0x?
00.
F. 00?
F, ma'am. F.
FF, then 4 zeros, correct? Okay, then, so IO pin is loaded with this value. Okay, and then, what should be the direction register? IO0, DIR should be equal to 0x. All these pins, the corresponding pins, these 16 to 23 should be outgoing pins. Okay, so hence, for the make outgoing 40, then these bits of DIR register also should be 1 and 1. Okay, and then what should be done? So you have to send this data. Right now, everything is ready. Outgoing pins are ready, data is ready. What should be done? You have to send data and then call delay. Okay, right. After this delay, again you okay. So again you have to send, first you have to send FF, okay, and then you have to send 00. Again you call delay. That's all is the program. Okay. I hope you have understood this. Then you have to write the delay subroutine function. So now, so you will be calling the delay function. So hence you declare that. So void delay only will take it as a variable. Is a declaration. Okay, you are not defining a function here. So it may. Okay, so and then start this. You are defining a function here. Okay, so and then okay, pin select also we need to do pin SEL0 is equal to all are GPIO 4, 6, 5, 1, 2, 3, 4, 5, 6, 7, 8. And then what? IO0 DIR should be equal to 0x00 FF 4 zeros. Okay, and then so enter the loop. Okay, so while okay, so you start this loop. Right now we pass the data IO0 PIN is equal to 0x00 FF 0000. Okay, then what should be done? Delay. Okay, here delay function is declaration. You are not defining here. See here this delay function, it is a declaration, declaring that. So when you, later you will be writing, defining this delay function. Okay, right? So and then delay. Then after this delay, pass zeros. 0, 0, 0. Okay, all zeros. Then call delay. Okay, so and then close this loop, close this loop. Right, then define this. Here you have declared and here you have to define. Okay, void delay void. Here semicolon will not come because here you are defining the function. Okay, then unsigned you declare a variable for the loop int I is equal to 0. Then for I is equal to 0, right? I less than or equal to some value you take 60,000 or something. Okay, I plus plus. Right. So and then close it. Okay. So here you see this is a delay subroutine. I just write. This is delay function. You're calling this delay function here. Here you are declaring the statement. Okay. So here you are defining the delay loop. Right. So I hope you have understood what are the requirements. Okay. So you have to declare here. Declare here what function that you are calling in the main program. Okay. So then this is the initialization. Pin select 0 should be all zeros because GPIO mode, and direction of 16 to 23 should be fixed as outgoing pins, and enter the loop. Okay, so and then you pass ones for certain interval of time. Okay, and then you pass zeros for certain interval of time. Then you complete the delay subroutine. Did you follow this? Passing logic ones to DAC. Okay, here passing zeros to DAC. Okay, so this part of the program is passing logic ones to DAC, and this part of the program is passing zeros to DAC, and this part of the program is function. Did you understand?
Yes, ma'am.
Okay, it's a very simple program, right? You should know the concept. What are we doing here? If you understand the concept, no. So if you imagine the diagram, whatever I had written previously, you can write the program yourself. Okay, I need to generate a square wave. How do I do? So I need to send some data. Where I have to send the data? From where to where? Okay, so from microcontroller. So microcontroller, how actually sends the data? Through the register. So first I have to place the value into a register. And then whatever the value that you're going to place it in a register, that definitely will, placing a data corresponding port. Okay, so and then port will be connected to DAC. Okay, so then the data available at the pins, right, depending on the direction and all, everything is made ready. Okay, so whatever the data that is placed on this value register, that will reach DAC, right? So and then logic ones are being sent to the DAC and it will generate this part of the program. This part of the waveform, high level. And then here this generate the lower region of, sorry, this is the lower region and this is the upper region. Okay, so here this is the lower region, 0 level. Okay, this is 1 level. Okay, upper part of the waveform is created by this part and lower part is created by this one. If you join, no, so it will be in the loop. Okay, unless you stop. Okay, so then it will generate a square waveform. So this is how actually we are writing a program or we are embedding a program in microcontroller, so that if you connect a DAC to my interface, a DAC to microcontroller, then if you write a program like this, then as a result of this, you will be checking, you will be getting a square waveform at the output of DAC, analog output of the DAC. I hope you have understood this program.
Yes, ma'am.
Okay. Then we shall move on to the next wave. Okay, triangular waveform. To generate triangular waveform should be generated. How do you generate? See, triangular waveform will be like this. Positive going for a certain interval of time. So this is a positive going region of the waveform and this is a negative going region of the waveform. Again, it repeats, positive going and then negative going. So it repeats. So this is a triangular waveform. See the shape difference. Previously, the data should be sent to the DAC was logic zeros for some time and logic ones for some time. In between sending logic zeros and ones, we called it delay. So that would generate a square waveform. Okay, so now actually we need to generate a triangular waveform like this. That means you need to send a suitable data to generate this part of the waveform. What is that? See here, at this interval, let us say its value is 0. Okay. At the next interval, you see at T1, its value is different. Next interval at T2, its value is different. At T3, its value is different. At T4, it is different. At T5, it reaches a maximum value. Let us say this is F. Because in digital system, 0 is taken as, analog 0 is taken as 0. And so maximum value is taken as F. Usually, if you take 8 bits, no, so it will be represented as FF. If you take only 4 bits, it is F. Okay, so if you take 16 bits, there will be 4 Fs will be there. So depending on how many bits that you are going to use for representing a value, so that changes the number of hexadecimal digits here. So maximum value, if you are using 8 bits, means it is FF, 0 to 255. All of you know that. So by hexadecimal representation is FF, and analog value will be ranging from 0 to 255. Okay, so 0 to FF stands for 0 to 255 decimal. All of us know this. So here minimum value is 0 and maximum value is FF using 8 bits. Right. So in between 0 to FF, right, do you see a single value? Do you see a single amplitude or single magnitude between 0 to FF?
No, ma'am.
No. See, from the waveform only it is very clear. Okay, gradually the amplitude is changing at every interval of time. Okay, so here at interval T0, it was 0. At T0, it is 0, amplitude is 0. When you draw up vertical lines at every point, you see that at every interval of time. Okay, so the value keeps on increasing towards FF, and when it reaches FF, okay, maximum is FF or 255. Okay, then again it started falling down. Okay, so falling down means that again at T6 it is different, T7 it is different. Okay, at this point it is different. So what is the other limit? It is 0. So between 0 to FF, you see that at any interval of time, the amplitude of this part of the waveform keeps increasing. Okay. Again, between FF to 0, 0, okay, 8 bits if you are using, FF to 0, 0, you see that the waveform amplitude keeps falling and it is not same. Gradually, it is decreasing and it becomes 0. That means at every interval of time, okay, the amplitude falls down and it is not same. Right. Then what would be the logic to generate? So let me say, let us generate this part of the waveform now. To generate this part of the waveform, what data I need to set? So initial value, let's just say using 8 bits or 16 bits. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So it's equal to FF, let us say. Okay. So initial value at this point, you will send this FF to DAC. Okay, so it was square waveform and the other example. So like only 2 levels it has. So we sent 0, 0, we called a delay, and suddenly it was going to 1, 1, and it was generating, high level for certain interval of time. Okay, as long as you send FF, no, it will be generating high level value. Okay, so here it is not like that. In between, we have different ranges of values of amplitude. Okay, so then, okay, initially we know that we need to send 0. Because it will start with 0 amplitude. Then what should I do for this? What should be done? What should be done? See, I need to generate this part of the waveform now. Now somebody is joining. One program is over. What should be done? Zero, zero, I have sent. What should be the next value? What's the maximum limit if I start with 0, 0? If I start with 0, 0 at this point, what is the maximum limit?
16.
No. What is the maximum limit? See, 0, FF, no?
Yes, ma'am.
FF is a maximum limit. What's the minimum limit I am starting with?
0, 0.
0, 0. All 8 bits will be 0, 0, 0, correct?
Yes, ma'am.
Okay. So this is equivalent to 0, 0 hexadecimal. Okay, or 0x00. Now, what is the maximum limit it should reach?
FF, ma'am.
Okay. 1, 1, 1, 1, 1, 1, 1, 1. This is equal to FFH. Okay. So only this level and this level are there, or in between there are many levels.
In between there are many levels.
Many levels, right? How many levels are there?
4, ma'am.
No, here in example I have shown 4. Okay, I cannot show all, right? Okay. So how many levels would be there?
Infinite.
Huh? How many? See, minimum limit of this combination 8 bits is 0, 0, 0, 0, and maximum limit is all ones. What is the next level?
32
Next
levels.
binary combination is 1, no?
32 levels in between.
Not 32. What is the next combination?
16.
Correct. What is the next combination? What is the next?
1, 0, 0.
What is the next?
1, 0, 1.
Right. So I cannot write all. Right. So how many combinations you can have if you have 8 bits?
2 power 8.
Yes. Correct. How many bits you have here? 8 bits. What's the minimum limit? 0. What's the maximum limit? FF. How many combinations you can have if you have 8 bits representation? 255 combinations you can have. Okay, can you write it manually?
No, ma'am.
No, but computer can do, no?
Yes, ma'am.
You put it in the loop. Okay, right. How long the loop should increment?
255 times.
Yes. Okay, it should start with 0. Okay, till it is not equal to, right? So not equal to symbol is this, not equal to FF. Okay, so I you are taking I is equal to 0. I not equal to FF. What should be done? I plus plus. Correct?
Yes,
Correct?
ma'am.
Did you understand this? See, you understand this. Okay, 8 bits are there. It starts with 0. Right, 8 bits means all 8 bits will be zeros. What is the next value? It should be 1. Okay, because it's a 8-bit representation. Right. So it is not that one value this triangular wave has. It has 255 values will be there. 255 amplitudes will be there. So if it has 0, 0, 0, 0, 0, 1, it is one amplitude. If it has 0, 0, 0, 0, 1, 0, it is a different amplitude. If it has 0, 0, 0, 1, 0, 1, it is a different amplitude. So like that, it has 255 levels from 0 to FF. Will you agree that?
Yes, ma'am.
Yes, okay. So then between 0, 0, 0 to 1, 1, 1, there will be, we know that, we are very sure that there will be 255 levels. Okay. So this positive going portion of this waveform has 255 amplitudes or two different 55 magnitudes will be there from 0 to FF. Now, these values we have to send to DAC. Okay. Right. One by one we need to send. Followed this?
Yes, ma'am.
Okay, so now how do we set this? I'll write a program now. So this value is placed on which register? So if you place this value in one register, can you keep on incrementing that register value?
No, ma'am.
Previously what we did, we placed IO0 PIN is equal to 0x000. 8-bit value we placed. And we called it, we sent this and we called it delay, and again we passed FF on this, only 2 levels. So it was so easy. Right. So here you need to place 255 values into this IO pin register. So how do you put IO? We cannot put IO pin register in the loop. Can we put that?
No, ma'am. We should take variable.
Yes, you should declare a variable. Okay. Then you should assign that variable value in the memory to this register. Followed this? So let us declare a variable in the loop and we keep on assigning that variable value as and when it increments, no, that value is assigned to IO pin. As and when that value is assigned to IO pin, that will be placed onto port, and then port will send that value to DAC, and DAC will convert the value. Did you understand?
Yes, ma'am.
Okay, so what is happening here? IO pin register itself cannot be incremented. See, if you place 0, 0, 0 to IO pin register, next value should be 1. Next value should be this. Next. So like that, there are 255 values are there. So we cannot put directly this IO pin register in for loop. Okay. So what we do? We take a variable I. So like this. So this I, what it does, initially I will be equal to 0. This value. Okay. So I will be 8-bit. So I will be equal to 0. Right. So and then, so what actually you do? You send this, you create a temporary location. Okay. You assign that value to temp. Okay. So and then from temp it goes to IO pin. Okay. Then again increment I. Again you assign that value to temp to IO pin register. Again you increment the value of I. Okay. Again assign that value to temp and it will go to IO pin register. Okay. So like that, like this, it will be in the loop till it is equal to FF. So you have to increment the I value till I not equal to FF. Okay. I not equal to FF, you have to, as soon as it becomes equal to FF, then it have to come out of that loop. Followed this?
Yes, ma'am.
Okay. So now let me write a program. To write a program, you have to understand the concept. Otherwise, simply mugging of the program is of no use. You should not do that also. Being a software engineer, should never do that. All are software engineers only. Medical electronics students are also doing a lot of codes. Without codings, okay, no branch is there today. Right. So now we have one temporary location also. So here you are declared. So below this, you can declare the variables unsigned, okay, long, and temp. Temp is a variable, type is int, and it is long, 32-bit is there, so it is long int is equal to assign this value initially. It is 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8. One more is there. So if you can say, or otherwise I'll write this side. Unsigned long int temp is equal to 0x 1, 2, 3, 4, 5, 6, 7, 8. Okay. Declaration. Then we have unsigned int I is equal to 0. But also starting with 0. Then these are all initializations. IO0 dir is equal to 0x 00ff. We are making these pins as outgoing pins. Okay. So do we have to use IO pin here itself?
No, ma'am.
No. Okay. Let us see later. Enter the loop. Right. So and then open this. Then let us declare temp. For loop we shall declare for I is equal to 0, I not equal to ff, okay, I plus plus. Right. And then here temp is equal to I. Temp is equal to I. Okay. So then temp is equal to temp left shifted 16 times. Then pass the data to IO0 PIN is equal to what? Temp. Right. Close this and close this. And we have, yeah, before closing, we have to enter another loop. So for I is equal to decreasing, no? FF 0xff upper limit, falling part of the program, I mean waveform. So here you have done this part, upgoing. Okay, so now it is falling edge of the waveform. So I mean initial value of I is ff to 0. Hence initial values of I is 0xff. Okay, I not equal to what? I not equal to
0.
okay. I not equal to 0. What should I do now?
I minus minus.
I minus minus. Okay. So and then right. So open this. Right. Again do the same thing. Temp is equal to assign the value of I. Okay, to a temporary location. Then okay, temp. We are doing something for temp here. I'll tell you later what is that we are doing here. Temp. Okay, left shifted 16 times. And then you are going to assign the value to IO0 PIM. What value? Whatever that is there in temp. Okay, and then close. 3 are there. Okay, I hope some part of the program you have followed, not completely, maybe. So you know like why we are creating this value, because each and every time for all the 256 values, so we cannot put IO pin register in the for loop. So hence we are creating a temporary location in the memory and we are placing all zeros there. Okay, all the 32 bits are zeros there in a variable temp. Okay, so now we need one more variable for loop, I is equal to 0. So now dir register should be assigned with this value. 16 to 23 are outgoing pins. So now start this one. So now we have come to the actual part of the program. Okay, so where we'll start with 0, this value 0. Okay, positive going side of the waveform, and 0 to FF. Till it is not equal to FF, you have to keep incrementing. Okay, that's the meaning of this for loop. I is equal to 0, it start. Till it is not equal to FF, you have to simply keep on incrementing the value of I. So I plus plus. Now, you assign, say for example, what is the first value? Can you tell me? First increment will produce what value? Correct? Can you see? I hope you cannot see. What is the first value that is being assigned to this temp? Or what is the first value of I? What is the first value of I? Initial value is 0. When it gets incremented, now what is the first value?
0, 0, 0, 0.
The first value is 0, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7. Last one will be
1.
1. Okay. So this is the first value of I after incrementing first time. Okay. When it is doing I plus plus, no, the first value of I will be equal to 0, 0, 0, 0, 0, 1. So that value is assigned to temp. Correct?
Yes, ma'am.
Okay. Now you see what is being done here. You see this line. Where is temp? See, temp is like this. Okay. When you assign I value to this temp, right? How actually the bits are being placed here? It will be like this only, no? Temp value will be equal to what? So now temp becomes, I'll write this itself. Temp is equal to this will be the value, correct? Because I value are assigning to temp means, now temp takes this value, correct? Yes or no?
Yes, ma'am.
Okay. Now, why are we doing this temp left shifted by 16 bit?
It should come to 16th.
Very good. Okay. So it should come to, because you see, you are sending the data from which register? To port IO pin register. Correct. See, whatever the memory location data we are assigning here, finally it should go to register only. From register, it will go to where? Port only. Okay. So now our aim is to send that suitable data to IO0 PIN register. What's the first value? This is the first value after the first increment. Okay. So now this value is assigned to temp. So we know that temp value will be set to IO0 PIN register. So directly if we send this the same data without shifting, okay, so what will happen? What will happen? Because later you are assigning that value to IO pin register. So without shifting, right, let me write, I don't shift now. Okay, so simply I assign temp value to, without anything. Okay, I mean, let me skip this line. Let us assume this line is not there. So I value are assigning to temp value are assigning to IO pin register. What will happen?
Increment will happen in pin.
No. Which pins of IO pin register will receive a data as one?
Pin 1.
Correct.
Pin 0.
Okay. Pin 1. Right. So pin 1 will receive the data as, I mean, bit 0. Okay. Bit 0 of IO0 pin register will receive data as 1. Okay. So the same thing will be placed onto port 0, right? So that means P0.0 will be equal to 1, correct?
Yes, ma'am.
Okay, but according to our declaration of IO0 DIR register, through which pins of port 0 we are sending the data?
P0.16 to
Yes,
P0.
we are sending the data from P0.16 to 23, those 8 pins. But if you don't shift the data 16 times left, okay, so if you simply assign the value to IO0 pin register, so instead of this one being placed at the 16th position, see here, 16th position, okay, it will be placed at this point, right? But data will not reach DAC at all. Understood? Okay, so hence we have to shift this value so that this one bit this one bit after 16 times 4 hexadecimal digits, 16 binary. Okay, so 16 binary, right? So 16 binary bits are there. After left shifting 16 times, this one will come and sit here, okay, at the least significant bit of F. Okay, what is that? 0, 0, 0, 0, 0, 0, 1. Okay, the last bit of this, right, this position, right, will receive 1. So to do that, we need to shift the data present in temp by 16 times, correct?
Yes, ma'am.
I hope all of you have understood. So hence, so this temp should be left shifted by 16 times so that whatever the value that you are incrementing, okay, this here 0001, that should fit into only from 16 to 23. Now it is at LSB if you don't shift. Okay, from LSB 16 times if you shift no, then it will come to the 16th position. Okay, so that is what we are doing here using this statement. Okay, right. So then we can assign that value. First value is what? This. Then you are assigning that value from temp to IO pin register. Then from IO pin register, it will reach. It will reach.
DS, ma'am.
Huh?
DAC.
No, before that. When you place this value to IO0 pin register,
Port,
okay.
ma'am.
So data will go to where?
Port 0.
Okay, port which pins?
16 to 23.
16 to 23. Those 16 to 23 pins are connected to the data pins of DAC. Then DAC will receive the information. Then 0001. This binary information is converted into analog output. Say it may be some 0.5 volts or something. Okay, it was 0. It may be some 0.1 volts or something. So next increment will be 000010. This is equivalent to 2. Right. So like that, this loop will be there in, will be incrementing till it reaches FF. Okay. So in here you have 255 values in between that is assigned to IO0 pin register, and then it keeps sending to port, and then port will send the data to DAC register. So as a result of this, you will be getting this positive void ramp. Followed?
Yes, ma'am.
Okay, now we enter the second part of the waveform. So what is that initial value? FF. Right. So till what value you should repeat? Till it decrements to 0. I minus minus. Again same thing. So that is upper values all ones will be there. Okay. Right. So these all ones should come to 16 to 23. So then you have to left shift by 16 times. Then all ones will come to 16 to 23 and fit. Okay. So then you assign that value to, okay, IO pin. IO pin will receive now what? FF at 10. Then again you decrement. What is the next value? All ones. Okay, and then 0. What is the next value? So again decrement like that. So again there will be 255 values in between FF and 0. So as a result of that, you will be getting a negative going ramp. So it will be in the loop, right? So it will be generating positive going and negative going part of the waveform. So that results in triangular waveform. I hope you have followed this.
Yes, ma'am.
Right? So any doubts you have in students? Any other students have any doubt? Only 55 are there. What is this? It's such an interesting topic. You lose the information. Even if you read the book also, see, in the book, no, they'll give only this program. They will not say why it should be left shifted by 16 times. So how actually this bit pattern will be there in temp, and all those things, explanations will not be there. Unless you don't understand, how do you enjoy the program? Simply reading the program and mugging up the program, definitely I think will not enjoy the program. As a computer science or any other branch students, any program, even if it is a few lines, you should understand and enjoy writing program. Okay, so computer will take care of doing 1,000 times or 2,000 times. It will take care of. You need not put it in a loop. That's all. Okay, it is his job to take care of. Iterating several times. 1,000 times you give also, it will iterate for 1,000 times. Okay, but only thing is you should know. Okay, what to tell computer, what to do, how to tell. Right? Unless you know something, no, you cannot instruct computer to do whatever you want. Right? So I hope you have understood both the programs.
Yes, ma'am.
So tomorrow I'll be discussing the program for sine wave generation. It's also very interesting, though it is also a very small program. See, program small or big, okay, you will not know. If you keep on writing the program yourself, you will not know how length it is, how lengthy it is, how big it is, right? Okay, so if you understand, no, simply the lines will keep on increasing. That's all. You have to understand writing the program. You should know the logic and algorithm. So anyway, tomorrow I'll be discussing sine wave program. After that, I'll be discussing UART. Okay, I mean, tomorrow shall I take or Thursday shall I take? As you wish. So if I take tomorrow and day after tomorrow, Thursday, probably I'll be completing.
Okay, ma'am.
So Thursday, Wednesday and Thursday. Okay, all right. Because for you also test will be approaching, then you will not have time. Okay, so if you give me time tomorrow and day after tomorrow, I mean almost all interfacings I'll be completing.
Yes, ma'am.
Is it okay? Okay.
Yes, ma'am.
Ask all the students to attend. If they miss, no, then it is a huge loss for them. Once the college starts, begins, and then labs and all will be offline. Okay, if you don't understand the program, you will be facing a lot of troubles in the lab also. I tell you. Theory also, theory exam, probably if it comes to as an offline exam, last time it happened, no? Then I saw like students who did the test in online examination, they scored well. But once it commences with offline, then I mean marks came down like anything, single digit. See, scoring marks is not important. Understanding the things is very important. Keep on telling you always. So try to understand the things. Very huge competition is there. Okay. So last week also 4 students got selected in Accenture. Right. So because of their ability. It is not like by how they use the shortcuts to score marks. That and all did not matter there. It is their talents, their ability, their skills. Okay. Took them to different places. So I suggest you try to understand the subject, don't waste your time. So each and every day matters you a lot. Okay. So anyway, 55 students are there, 56. Very poor attendance. I pity them. They're losing. Okay, let me call the names and wind up. Sneha,
Present, ma'am.
Prajit, Prakash, Prasan Kumar, Pratiksha,
Present, ma'am.
Praveen,
Ma'am,
Prerana.
69 present, ma'am.
Present, ma'am.
Okay.
Ma'am, 69 present.
Allappa, when I called, you did not answer. Why you are answering now?
Ma'am, network issue, ma'am.
No. Don't tell all those things.
No, ma'am.
Then only you will have network issue. All of a
Ma'am,
sudden,
2 3 only. 4, ma'am. 69, 72 only. 73, 4.
Okay, Pratik Jagrati.
Ma'am, 69, ma'am. Ma'am, 69. Prasan Kumar.
Mark it.
Yes, ma'am. Thank
Prerana,
you.
Present, ma'am.
Priyadarshini, Ravi Teja,
Yes, ma'am.
Sachin,
Present, ma'am.
Sachin MT,
Yes, ma'am.
Sandesh,